Good morning, everyone.
Good morning po.
Good morning, Jonas.
Morning, sir. Um, I I heard we're just waiting for one member of the panel before we can start. Okay. I guess we can start now. So good morning once again to all participants and members of the panel, my fellow project leaders in the ERDT, Dr. De La Cruz, Jennifer De La Cruz, Dr. Michael Pasis, and Engineer Phoebus Reeds Cruz, members of the panel. Good morning, and all participants. Um, I'm very glad that you were able to participate in today's session. I heard that this is the last one of the ERDT National Congress Research Conference. And now that there are now already 94 participants, I feel that this is going to be a successful mini session. And I also would like to bid good luck to the presenters, whose papers we will also be judging for the best paper today. And I would like now to take the honor of introducing our plenary speaker, who will talk about embedded systems in the Industrial Revolution 4.0 and Internet of Things. With us is Dr. Jocelyn Villaverde, who is a distinguished professor at the School of Electrical, Electronics, and Computer Engineering at Mapua University. She earned her bachelor's and master's science degree in computer engineering from the Technological Institute of the Philippines and her PhD in electronics from Chungyuan Christian University in Taiwan. And without further ado, I would like to introduce to you my colleague from Mapua University, Dr. Villaverde.
Good morning, Sir Jonas. Thank you
Good
for the
morning.
introduction. So I will just share my screen. Hi. Host, can you please enable the sharing of screen?
Yes, ma'am.
Thank you. So habang hinihintay natin, gising na ba kayo? Good luck to all the presenters later. So
Yeah.
ako muna yung mauuna ngayon. Okay. Okay na. So, whiteboard. Hindi ko pwedeng i-share yung screen. Parang application lang yung nasi-share. Anyway, sige, ano ko na lang later. Okay. Okay.
Ayan, meron na.
Okay. So, good day, everyone. So, thank you for the introduction, Dr. Jonas. So, basically, this talk will give you an overview on the embedded systems, Industry 4.0, and Internet of Things. So, before I proceed with my talk, i-off ko muna yung camera ko, ha? So, medyo hindi ako sanay nakikita yung sarili ko, eh. So, i-off ko lang yung camera ko. Okay. Okay. So, that's it. Ay, sorry. Click ako. Okay, so let us first define what is Industry 4.0. I'm sure all of you heard this one. And basically, yung iba sa inyo, this is the first time you will be hearing Industry 4.0. But I'm sure most of you already heard Industry 4.0. So when we say Industry 4.0, normally this refers to a new phase in industrial revolution, which focuses primarily on interconnectivity, automation, machine learning, and real-time data. So there are actually 9 pillars for Industry 4.0. These are the core technologies which make up the bulk of the manufacturing process in the new paradigm. So this is actually the future and present of manufacturing. So first is the simulation. So one of the core technology is the simulation. This leverage a real-time data to reflect the physical world of product development and production in a process of virtual environment. So this model can be used to run efficient tests so that settings and processes are optimized before production even starts. This will reduce downtime and improve quality. So this also helps engineers to visualize the design in a much better manner, consequently helping them identify problems and obstacles in the early stage. I'm sure all of you are familiar with simulations since most of you also did simulations when you do your paper or research. The next thing is the horizontal and vertical system integration. So for Industry 4.0, this is all about improving connectivity. Since when we say interconnectivity, so all machines should be connected. So not just between machines. Many manufacturing information systems are currently not fully integrated. With the improved system integration, companies can become more interconnected both externally and internally. So this will result in a responsive manufacturing environment, which will allow the real-time production corrections and quick workaround. So every devices and systems at the manufacturing level will have the same facility, or the other is connected with each other. As this enables communication between systems, so there are different facilities. The jobs can be planned and adjusted by the machines themselves. So it also limits the downtime with that will compensate the overtime of the employees. So with this, there will also be a possibility that there will be no human intervention. So when the system will detect some errors, so what the system will do is it will immediately notify the concerned department. So whether it needs to be repaired or there are products that needs to be consumed or needs to be supplied. So this is what we call the system integration. For the Internet of Things, of course, if we have system integration, so basically you need Internet of Things. So what is Internet of Things? For Industry 4.0, we refer IoT as Industrial Internet of Things or IIoT. So IoT refers to the networking and connectivity of the smart devices. In the world of manufacturing, this technology is often referred to as what I have said, it's industrial Internet of Things. So manufacturers are attaching sensors to the machines and other physical assets on the plant to collect data, which influences decisions real time and leads to increased efficiency and productivity. So this is where embedded system takes place. Another core technology for the Industry 4.0 is the augmented reality. Augmented reality is basically used for Industry 4.0. So I'm sure you already use AR in your smartphones. So AR displays digital content in real world through the devices such as your mobile phone or a special eyeglasses. There are also a number of different technologies that uses in the manufacturing industries. But today, we have these remote repair instructions, which can be sent to literally any part of the world with internet accessibility. So later, I will also show you a simulation for the Industry 4.0 where you can visualize AR. So it helps technicians to enhance their skills by practicing high-end repairs and maintenance over and over again using augmented reality. The next one is the additive manufacturing. So while manufacturers are looking to expand the use of additive manufacturing in their processes, normally they use 3D printing. So they use 3D printing for design, prototyping, and of course, the low volume production. So this plays important role in the additive manufacturing. So aside from that, the next primary concern is the cloud. So since we need connectivity, we have lots of data or information. So cloud computing basically is important. So when we say cloud, this is a remote system that can be accessed to provide anywhere using the internet. As the technology and data sharing of the manufacturing company grows, so cloud computing provides scalable storage. So you cannot store uh, your information or your data for just the for your internal server. So you need cloud to store those informations. So this can be integrated, for example, this can be integrated in PCB factory as well as the supply chain. So the next one is the cybersecurity. So as connectivity increases, the risk of the potential cyber attack grows alongside. As more and more components get connected and one device's action is based on the output of another device, more operational decisions are decentralized. So more security concerns are raised. Any security breach could damage multiple areas in the business, starting from the supply chain to its operation. So it's absolutely critical that companies prepare and protect their information system and production line for cyber threats. So basically, this is really important. So if you have lots of data and information, cybersecurity is very important in your system. So this prevent a catastrophe and safeguarding the data and performance of the server in the sole purpose of cybersecurity. So next one is the data analytics. So this is the common among all these pillars and new technologies is the data collection and analysis. There are massive amounts of data in the manufacturing industry, and we are just beginning to scratch the surface. So it's important for manufacturers to have tools so that they can visualize their data. So what are their tools? So one example of that is the dashboard. So this will help them clean, organize, and visualize the massive amount of data available. In the end, this will free up also the time to analyze data, communicate insights, and optimize inefficient process. So the last pillar is the autonomous system. So while the manufacturing industry has a great strides when it comes to automation over the last few years, there is still a lot of opportunity. So collaborative robots are designed to fill the gaps between the traditional robots and human workers and open up a new era for automation. So these robots are designed to work in ways similar to humans with the added ability to monitor and transmit data. So for the autonomous robot, there is also an embedded systems in this part. Okay, so therefore, Industry 4.0 is the digital transformation of manufacturing, production, and related industries and value creation process. So I'll just go over the history of the Industrial Revolution. So until 4.0. First, we have Industry 1.0. So it starts with Industry 1.0. The first industrial revolution is the transition from the manual labor to steam engine, where the mechanical advantage of the steam engines were leveraged to lessen the human labor. The usage of water and steam power on all sorts of machines. This would lead to the industrial transformation of society with trains, mechanization of manufacturing, and loads of smugs. So after Industry 1.0, next is the Industry 2.0. So the second industrial revolution is typically seen as the period where electricity and manufacturing inventions is enabled. So such as the assembly line, which lead to the area of mass production and some extent to automation. So this also where we have now the electrical motors and analog systems were replaced by the steam engine. So there was a little to no manual labor involved in Industry 2.0. The next one is the Industry 3.0. So this had to do with the rise of computers, PLCs or the programmable logic controllers, and electronics in factories. This made possible for humans to program the machines. So also for the Industrial 3.0, computer networks such as wide area network, local area network, and metropolitan area network. Okay, kala ko may question. Were introduced. So the rise of robotics in manufacturing, connectivity is also the birth of internet in Industry 3.0. Okay, the last one is the Industry 4.0. So the fourth industrial revolution, this is the bridging of digital and physical environments. So in manufacturing, normally this is referred to as the cyber physical system. The coverage of IT and OT, or OT stands for the operational technology, and the Internet of Things such as the big data, the cloud, the 9 pillars that I have mentioned a while ago, with additional accelerators such as advanced robots and AI cognitive, which enable Industry 4.0 with automation and optimization in the entire new ways that lead to ample opportunities to innovate and truly fully automate and bring the industry to the next level. So we now have here the smart factory, the autonomous system, IoT, and machine learning. Okay, so what are the basic concepts for Industry 4.0? Actually, we have four. So these are the interconnection, information transparency, technical assistance, and decentralized decision. So when we say interconnection, this refers to the ability of technology and people to communicate effortlessly in the smart ecosystem. This is heavily linked to the IoT or Internet of Things concept. So as you can see here in the diagram. Next is the information transparency. So as the name suggests, this refers to the use of data and statistics in manufacturing process to allow for innovation and improvement as well as targeted troubleshooting of problems. Next one is the technical assistant. So technical assistant in Industry 4.0 means that humans no longer have to calculate and solve problems manually. With the aid of computing software and simulators, we can make things easier to visualize. So technical assistance also refers to machines taking over physical tasks, which are either unpleasant or exhausting for workers. So that's the good thing about this one. Then the last concept is the decentralized decision. So finally, as everything is either automated or controlled remotely, cyber physical systems are able to make decisions on their own and perform tasks in an autonomous manner. The only exemption to this rule is the event of the technical error or conflicting goals. So for this part, we will be focusing more on the interconnections and the CPS or the cyber physical system. Okay, so for the cyber physical system, so this is the building block of Industry 4.0, CPS. So these were all the sensors and actuators and other elements which are part of the Internet of Things. So the CPS are based on the latest control systems, embedded softwares, and also IP address. So since we're dealing with sensors and actuators, so we have their embedded softwares. We also have internet, so that's why we have IP addresses. So cyber physical systems are also equipped with sensors, actuators, and all other equipment as I have mentioned a while ago. So the exact connectivity technology which are needed depend on the context. The CPS normally comprises of sensors, microprocessors or microcontrollers, and actuators which constitute to the technological core of Industry 4.0 and enable a real-time data transfer. So this is where embedded system takes into account. Okay, so what is an embedded system? For the CPS system, these are intrinsically connected with embedded systems. These are being part of the complete devices carrying out dedicated functions that frequently come with real-time computing constraints. An embedded system is a combination of hardware. So you have here your hardware component as well as your software component, which are capable of performing a dedicated task. So when we say dedicated task, the design of your embedded system primarily focus on a specific task or specific applications. So most of the embedded systems need to meet real-time computing requirements. This capability has made embedded system an integral component of industrial controls and automations for decades. So what are the applications of embedded systems? So I'll just go first for the domestic application. I'm sure all of you, or we are surrounded with embedded systems. Domestic appliances are all embedded systems, your microwave, your refrigerator, your washing machine. So everything falls under the embedded systems application. Next is the audiovisual equipment. So as you can see, we have smart TV. So also your MP3 or what's the latest sound. So hindi ko na alam kung ano yung latest sa sound. The MP3 lang alam ko, sorry. So you have the latest technology for your audio. You also have the gaming console. So telecommunication equipment. And embedded system is also used in medical devices. And then cars and vehicles. So normally ito yung Tesla. So they have different sensors in their cars to have autonomous driving. There's also a motion sensors. And the last one is the manufacturing equipment. So one of the biggest industries in the world is the manufacturing. This has been highly affected by the introduction of technological innovations, including embedded software for quite some time. So today we can call it a smart manufacturing. So due to the active implementation of robotics, IoT, AI or artificial intelligence and big data into production process. The only disadvantage of this one is medyo less yung worker na kailangan. So kasi puro machines na yung gumagana. So dozens of devices from small size sensors to large sophisticated units can be found at any factory. So their functions vary from online monitoring and remote control of manufacturing equipment to data collection and replacing people on the assembly line. So this is the block diagram of the embedded systems. So it is basically composed of sensors, processors, and output interface. So sensors are called a transducer, where it converts a physical phenomenon into a measurable electrical signals. And those signals will be passed through the sensor conditioning circuit or the signal conditioning circuit. So this is where the analog to digital converter is done. So basically most of the sensors, most of the electrical signals or the phenomena signals are analog. So it needs to be converted to digital so that the microprocessor can process those information because The microprocessor can only understand digital signals. So that's why the signal conditioning circuit here is very important. Also, aside from ADC, we can have also here the filtering, and aliasing is also a part of the circuit. So next is the processor or the microcontroller. So this is the brain of the system. It processes all the digital signals from the sensors and interpret the results. The good thing about embedded system compared to the computer system is the output interface. So you can directly connect your actuators and indicators to the IC of the microcontroller with the use of the output interface here. So a microcontroller is a self-contained, fully functional computer with built-in peripherals. Also, the idea of the microcontroller uh, is it can stand alone and it does not require any other circuitry to do a useful task. So these are the different examples of microcontroller. We have your 8-bit microcontroller. Uh, it is from Microchip. So if you see here Microchip, the basically the part number for Microchip microcontroller or starts with peak. So peak and then the different numbers. And then we also have here an Atmel, an example of a microcontroller also. So we have 8-bit, 16-bit, 32-bit, and 64-bit microcontroller. So as I have mentioned, the common microcontrollers that are used are PIC microcontroller, which is from Microchip. The Arduino board uses Atmega microcontroller. So we have here the Arduino. And also this is a Raspberry Pi, which is a single board computer. Okay, so this is the Raspberry Pi. So, and the different parts of the Raspberry Pi. This is a single board computer which have a different or a set of GPIO. GPIO means the general purpose input output pins, which allow you to control electronic components for physical computing and also explores the IoT or Internet of Things. You can also implement a network between a Raspberry Pi and an Arduino for the control of a level plant, for example. So this is the Arduino. Actually, the good thing about Arduino is an open source. So open source prototyping platform. You have here the Arduino IDE. So you don't need to have a license. If you want to learn the basic concepts of embedded systems, you can start doing it with Arduino. There are basically lots of open source programs available. So if you want to explore the the different applications for embedded system, I am suggesting that you can start first with the Arduino board, which the Arduino IDE is also free. So this is, it uses a C language, and this is the introductory software for first-time learners of embedded systems. Okay, so after the embedded systems, we have Internet of Things. So Internet of Things, it consists of objects with embedded or attached technologies that enable them to sense data, collect them, and sense them for a specific purpose. So depending on the object and goal, this could be captured, the data can be captured in terms of movement, location, presence of gas. It can also sense temperature, health condition of the devices, and the list is endless. So the data is just the beginning, but the real value starts when we analyze and act upon them in the scope of the IoT project goal. So these are the different applications of IoT. So we have here the different sense. We have the position, motion, temperature, humidity, acoustic, so on and so forth. Okay. IoT devices can also receive data and instructions depending on the use case. So all this applies to cyber-physical systems, which are essentially connected objects. So to relate IoT to Industry 4.0, this is a system of interrelated computing devices, mechanical and digital machines, objects, animals, or people that are provided with unique identifiers or the UIDs. They have a unique identifier and the ability to transfer data over a network without requiring human to human or human to computer interaction. So this is also known as industrial Internet of Things. So why should the components communicate with each other? So what actually is the need to do so? So the revolution of the smart factory needs to advance devices capable of exchanging information in real time. The presence of the IP address, by definition, means the cyber physical system. As objects are connected to the internet, an IP address also means that the CPS can be uniquely identified within the network. So this is the key characteristics of the Internet of Things as well. So shown in the figure is the example of the combination of CPS and IoT, where you can have your smart factory. The cyber physical systems monitor the physical processes of the factory and make decentralized decisions. It is still similar with the existing factory setup, starts from the raw materials, then it will undergo processes to produce output or the final product. What added here is the information. Every information is digitized and stored into a server. Those information are used for data analytics using the different algorithms such as machine learning or artificial intelligence. So for a factory or a system to be considered Industry 4.0, so it must have the four basic concepts that was mentioned a while ago. It should be interoperability, information transparency, technical assistance, and decentralized decision making. So a cyber physical production system relies on the newest and foreseeable future development of computer science, ICT, and manufacturing science. So actually, this is just a 2-minute interactive video from IBM. So this is about smart factory, where you can visualize here the importance of the pillars of the Industry 4.0, the embedded systems, and the IoT. So I'll just stop sharing this one, and I'll go to the website. Where is, okay. Ayan. So, ito yung website. I just found this one when I'm actually looking for the Industry 4.0. The good thing about this one is you can view the simulation, what will happen to the company, and how the technology that was discussed applied in this system. So, this is from IBM. So, we'll just have here Play Factory. So, this is the smart factory where you have different sensors. So, one manufacturer doubled output without doubling their assets. So how can IBM support your company and more? So start by producing these orders. We need to produce 2,000 blue units and 3,000 tan units. So let's just start. Okay, so we have here, it displays here the throughput, on-time race. So these are the metrics that we will be using. So as you can see here, you have here the robotic arm. So let's say, for example, we have here an alert. So the system will give you an alert. A blizzard threatens your tan material supplier. So the risk will be, the risk of disruption will be 35%. So what will you do? So you can select anything and then it will display you what will happen. So choose how to transfer tan production to your other plans. So for example, I want to wait until the chance of disruption hits 75%. What will happen? So it will give you simulation. So for now, tan units are ahead of schedule, but supplies are higher at a higher risk. So you can see here we have the throughput, 76%. We have on-time production of 91%, and also the risk is medium. So I'll try to put it next. Okay. So these machines composed of different sensors. Artificial intelligence is also here. So you can actually diagnose the status of the machine So this one, vibration and temperature readings predict failure within 24 hours. What will you do? So you can decide what are you going to do. So maintain blue unit productivity as you fix the machine. So we can transfer the TAN order and retool all blue lines, or we can retool just one machine for blue. So TAN units would not be delayed. So I'll just choose this one and let's see what will happen. So it will give you a simulation based on the decision you choose. So you have the next. So TAN units remain at risk. So we have here, as you can see here, we have the risk is high. So the blue units are on track. Next, use Watson to fix your machine. So I am not promoting IBM. So baka kala nyo doon ako nagtatrabaho. So pinakita ko lang kasi ang ganda niya na simulation for smart factory. Okay, so it diagnosed the machine using AI. So what are the possible failure or what are the components that need to be repaired? Okay, so this will give you a feedback. So repair feedback can improve further prediction. So here you can predict what will happen to the machine. So Watson can interpret spoken feedback. So in their system, there is a voice activation or voice recognition. So the technician will just say something and then there you go. Okay, so the system will give feedback. So Watson has found the root cause of persistent failure. So it means it diagnosed the components or the materials inside the machine. So let's see what will be the diagnosis. So part A12 may fail after 375 hours. Operation if humidity tops 50%. So here there is also a prediction. So it can predict how the lifetime of the components, particularly inside the machine. So now we're going to analyze this one. Then let's see what happens. So all informations coming from there will be transmitted to the server. So that's just the simple simulation for embedded systems. For Industry 4.0. So this is the alert. No outage predicted for 30 days. All our orders are on time and on budget. So as you can see, it gives you the prediction. So now we have a throughput of 99% and the production is on time by 90%. And now the risk is low. Okay. Question. I will answer that later. Okay. Okay. Is my screen visible to you, the PowerPoint presentation? Or siguro stop ko muna to. Then I'll share the PPT. Kasi hindi ko ma-share yung screen. Per application yung nasi-share ko. Okay. Is my PPT visible to you?
Yes, ma'am.
Okay, thank you. Okay, so how does Industry 4.0 implement this one? Okay, what the implementation of Industry 4.0? So we'll start with, we have actually 4 sensors and actuators, systems and internal services, connectivity, new services, and ecosystems. So for the level 1, we have here the connect, what basically here is connect what should be connected. So this is the bridging digital and physical assets as information carriers and then connecting the unconnected. So the first layer essentially consists of the product and manufacturing assets and components which become information carriers as they address, localized, and identified through sensors and connected. Uh, Pretty much the foundation of IoT indeed. So this is also the foundation of IoT. Connect what needs to be connected, sense what needs to be sensed. And then it bridge the digital and physical and lay the foundation for the next level. The next level is the systems and internal services. So this one monitors and manage. Basically, it monitors and manage your implementation. So you built upon the connected layers of sensors, actuators, and essential data that sits a layer of services and systems that enables a new way in which the value chain is organized and managed. So here we meet applications such as energy monitoring and the management monitoring of the system and conditions of assets such as the machines, buildings, infrastructures, and so forth. So in other words, mainly monitoring and managing. We do monitor for a reason to enhance, understand, and build new capabilities. The next level is connectivity. So connect for new applications and capabilities. Adding the additional layer of connectivity whereby not just assets are connected, but also the data and monitoring system, we then come to IoT and IP services models, which enables smarter applications and new capabilities such as preventive, predictive maintenance, just what you have seen a while ago in the simulation, asset tracking, and so forth, initially this maintenance. So tracking and other applications focus on the internal operations, but of some, it becomes additional revenue sources when deployed and offered in the customer ecosystem context. So, for example, by offering maintenance contracts that could bring a new revenue or be offered as a service with the equipment you sell while lowering cost for yourself. So, normally you have here services and supports, and then your customer will have less downtime. The next level is the level 4. So we have here new services and ecosystems. This is the transformation. So the fourth layer finally is where you can leverage the capabilities and services and the data intelligence you have to really transform your business model depending on the context. So this could range from applications which enable consumers to tailor the goods they order and sell advanced services to come up with new revenue streams. Certainly when developing services within the ecosystem of data and possible partners. It's also here that you can start developing new services that mean a significant shift in your core business. So by aggregating the data and intelligence from your intelligence systems and those others with complementary systems and tapping into entirely a new customer segments. It's also here that we see industrial IoT data exchanges and monetization platforms. In this stage, it's not that much the technology that limits what you can do, but your vision and imagination. So so these are the benefit of the industrial 4.0. So you can increase the productivity. So example is you can have a higher level of automation, which reduces the production time and also enables better asset by utilizing and inventory management. Next one is flexibility. So you increase the flexibility. Manufacturing flexibility through machines and robots can be executed the production steps for large numbers of products. Of course, through automation, you can also increase quality. So how to increase the quality? So the products via sensors and actuators that monitor the current production in real time and quickly intervene in case of errors. The last one will be the speed. So you increase the speed from the first product or factory idea to the finished product through consistent data and the new simulation opportunities. Of course, for Industry 4.0, there are actually several challenges and risks. First is the definition strategy. This is the number one challenge. So most of the companies or manufacturing industry, uh, actually, I don't know if they are really into Industry 4.0 in the Philippines. So the rethinking of the organization and processes to maximize outcomes, understanding the business case. So because you need to understand the technology comes within. You also need to conduct a successful pilot. So before you can really implement this one, making the organization realize that action is really needed. And then of course, change management, company culture, and actually this is the major problem is the true interconnection of departments. So basically, when the capabilities, so interconnection, this one. So when the capabilities of the clouds are available, paano ito ipi-play? Wait, hindi ko siya ma-play. Okay, ayaw ma-play. Actually, this is a video, pero ayaw niyang ma-play. So when the capabilities of cloud are available in more spaces, you have here different interconnections. So all these data need to be stored in the cloud because cloud is scalable. Digital innovation that may have seemed too difficult or too time consuming becomes more attainable. So as we face the new normal, so this is where we are heading, not just in the industry. Actually, embedded system can also be applied in our home as long as there is connectivity. So with that, thank you for listening and stay safe, everyone. Okay.
Thank you, Ma'am Jo.
Very good.
Yeah, I will be having the floor is now open for question and answers. So I guess we have some of the questions. I already have one question here, ma'am. If you will be
Okay.
able to answer this. First is from Mr. Jerry Halibas. So he asks, do we have initiatives here in the Philippines that supports small medium enterprise for Industry 4.0 from the government?
Hindi ko po kayang sagutin yan. Pero actually, there are, as far as I know, there are funding agencies like Fisher, DOST, that have parang startup. So I just don't know if, actually, hindi ko kasi kayang sagutin kung galing sa government kasi hindi po ako taga-government. Sorry. Opo.
Okay, we have another one here, ma'am. In your own opinion, what are the possible disadvantages of the Industry 4.0 in our society?
Thank you. Actually, yan, if all the companies will, if all the manufacturing line will be automated, so definitely yung mga workers bababawasan. So yun yung parang nakikita kong impact niya sa society. There will be less workers needed in a manufacturing firm.
Okay. Thank you, ma'am. We also have one more question. So, ma'am, how about the benefit on energy efficiency? With all those complexities, is Industry 4.0 energy efficient?
Yes, actually energy efficiency is very good in monitoring using the Industry 4.0 because you have different sensors that can actually monitors the status of your machines, also the power. You can also measure the power consumption of a particular machine. You can also monitor the production line. So, yes.
I guess we also have one question from Sir Jonas. Oh, ba? So
So,
what
ba't ko yung
curriculum?
tanong?
Sir Jonas asked, what curricular changes do we need in engineering education to be attuned to IR 4.0 and IR 5.0?
Actually, sir, for the CPE, we already have specialization for Industry 4.0. Yes, but right now we are just offering, Mapua only offered actually, we focus more on embedded systems, unique security, but we also have one for Industry 4.0 also.
Mhm.
Yes.
Ma'am, I have a question.
Ay, bakit? Okay.
Ma'am, related to security, is there a somewhat an issue relating to the security of yung IoT natin in terms of the sensors, or are we still on that part or phase that the technology on the security of the sensors are being developed?
Actually, I think right now we are just on the developing phase. So basically, kasi when you do hardware security, it's really difficult. But we have the cybersecurity, as I have mentioned a while ago, with the 9 pillars of the embedded the Industry 4.0. And cybersecurity is really important because yun nga, kapag nahack kasi yung system nyo, there will be more possible downtime tsaka damage dun sa production lines.
Okay. Thank you, ma'am.
Thank you.
I'll be accepting more questions. Do we have any other questions from our attendees? I guess we have one more. Ma'am, there's another question. Can your educational model of Industry 4.0 in Mapua be shared to other universities?
What do you think, Doc Jonaps? Siguro naman. So, probably, actually po kasi yung what we have in Mapua is a specialization for Industry 4.0. It's just part of the students' option, whether they want that specialization or not. If you want, probably you can email me at jfvillaverde@mapua.edu.com. .ph pala, sorry. Or pag pinayagan ako ni Doc Jonats na i-share. Joke lang.
Pwede naman siguro. Wala namang, I think it's, anyway, we're teaching it already. So it's, I think, basically public knowledge already.
Yes.
Thank you, sir. I guess we have one more. Ma'am, one question again. I see na very important yung data analytics. Ano po yung most recommended programming language for us engineers to use when working in data analytics?
Actually, marami naman na data analytics platform. So you can, kung ano yung, marami silang ginagawa ngayon for big data eh. So they develop different language. It's up to you kung ano yung forte nyo, wala namang problema doon. So kung ano yung alam nyo, so yun yung pwede nyo gamitin.
Yeah. Thank you, ma'am. Do you have any other questions? I guess we could accept one more. None. I guess that's it. Thank you, Ma'am Jo. Thank you very much.
Thank
Thank you very much.
So I guess we won't be having any preparatory break anymore. So we will be in a few minutes. We'll be starting our first presentation. So first, we'll be starting with a presentation from the LSU. So I guess we can start our presentation. So our first presentation will be entitled I Love You, which is internet connected laboratory units with over-the-air programming capability, which will be presented by Alexander C. Abad from De La Salle University.
Hello. Please allow me to share my video. Presentation. Thank you. Share. Okay. Oops. Sorry. Here's the chat box. Okay. Can you see my screen?
Yes. Can see your...
Okay, yeah. I will be presenting the paper entitled I Love You Internet Connected Laboratory Units with Over-the-Air Program. By the way, just in case of breakdown, my exhibits are already shared through the chat box. I already put the links of my real-time setup as well as my real-time data logging. You can just click the clickable links at your chat box. Okay, thank you. Due to COVID-19 pandemic, we are forced to do online learning or distance learning. Unfortunately, some laboratory experiments need actual demonstration or hands-on experience. This presentation aims to mitigate the hardships in online teaching and online learning by providing teleoperated setup with over-the-air programming. The setup can be used not only for online classes during COVID pandemic, but can also be a learning platform for over-the-air programming as well as Internet of Things in the new normal. The setup can be teleoperated anywhere in the world. The goal of this presentation is to encourage the readers, students, teachers, and industry practitioners to replicate and expand the setup in this paper demonstration. The contributions of this presentation is to demonstrate one overall setup, the teleoperation, over-the-air programming with Raspberry Pi Zero camera with its real-time video feedback. Setup incorporates VHT11 sensor for temperature and humidity data log using ThinkSpeak Cloud. There's also a demonstration on the activation of servos for telerobotic application, as well as LED matrix display. The current setup is in Liverpool, UK, but we can control it from the Philippines. There's also step-by-step procedures, including links to different tutorials on how to replicate the setup. Given all the materials, one can replicate the overall setup in one day. The setup is expandable and scalable. One can create a mobile telepresence robot by controlling DC motors instead of servos. This is the overall setup. It is composed of servos and particle devices such as photons and argon. There's also the Raspberry Pi Zero with camera as the video feedback. Details of each devices will be explained later as we go along with this demonstration. Let's begin with a quick demo. Here is the link to the video for the overall setup that can be accessed through your web browser. And here is also the link to see the real-time humidity and temperature data log. These links are now being shared in the chat box. You can see or you can click them and see for yourself the actual video feed as well as the actual data log of the setup. I also shared to you the HTML file that you can open through your browser. To control the LED as well as the mini robot with the red hat. I'm not sure who among you will control first, but sooner or later you will see how can you control the robot from the controller in the Philippines controlling the robot here at UK. Here's the schematic diagram of the mini robot. The particle device photon is being used in this setup. The particle photon is like the Arduino. It has digital pins and analog pins. Here in this setup, I just use the D0 up to D3 pins. The 2 pins for the LED, red and green, and the 2 pins for the signal for the servo. The program in controlling the servo is very similar in controlling, like in the Arduino. By combining the two servos, you can create a fun and tilt movement. You can create this small, like a mini 2 degree of freedom mini robot. Here's the schematic for controlling 4 servos. In order to expand the pins to control at 16 servos, but for this presentation, we just use 4 servos. We can use the PCA 9685 module to expand the use of the photon, particle photon. I also use the DHT11 humidity and temperature sensor just to show that this particle photon is really like the Arduino. It can be used in data gathering or weather monitoring. Here's the schematic diagram for the L8x8 LED matrix using the particle argon. This particle argon is very similar to particle photon, except that it has additional module, which is the Bluetooth, aside from the Wi-Fi module. As you can see in this code, it uses the MAP7 29219 library for controlling the 8x8 LED matrix display. The codes, the writing of the codes are very similar to writing codes in Arduino IDE. There are other examples using the servo as well as the temperature sensor. Particle photon and particle argon are very much similar to Arduino, but in programming or updating the firmware, we are using Web IDE. So any computer can be used as long as it is connected to the internet to program the devices. Here's the results. The live video feed can be accessed using the N0. This is the link I created so that I can expose the IP publicly so you can see it. The particle devices can be programmed like the Arduino using C++ language. And you can also create an HTML file like the one I showed to you to access the devices using the device ID and the access code. We can create a remote control buttons and integrated in one web page. Here's the data logging using the ThinkSpeak. You can upload the data log and broadcast them using the ThinkSpeak cloud. This is a free, you can create a free account. Here's a short video clip of the actual testing. In this video clip, I'm controlling the 4-degree robotic arm. As you can see, there's a small movement. I'm incrementing 2 degrees, but as you can see, there's a movement on this arm. You can also control the LED. The green one is being lit up, and then the red LED, as you can see. You can also use the slider to control the arm of the mini robot. and you can swing it sideways. Using the HTML code that I shared to you, you can do this in actual mode. There is the digiclip I recorded during my uploading of the firmware to show to you that we can program. I just changed the message from the display on the display of the 8x8 LED. Using the flash or the upload, you can upload the code to the photon. Here's the currently text being flashed. It's DOS2 Nat Con 2020. It will be changed to Mabuhay as soon as the flashing is successful. So as you can see here, flash successful. You can now go back to the LED display. It will be changed now into Mabuhay, which signifies that the uploading is successful. In conclusion, the paper presented a step-by-step procedure including clickable link references on how to set up teleoperated electronics laboratory using Raspberry Pi and particle devices with over-the-air programming capability. This setup can be used not only for online classes during COVID-19 pandemic, but can also be used in teaching and learning platform for over-the-air programming and Internet of Things for the new normal. This study can be applied to telepresence, remote sensing, and monitoring, as well as telerobotics applications. Here are the references with clickable links that you can easily access in the web to replicate the setup. Thank you.
Thank you for that
Okay.
presentation, Alex. I guess we have one question for
Oh,
you.
oh.
Question is,
I'm sorry. Will it be possible for the before the question? I think I will be asking the help from Miss Lorraine for the actual demonstration. I'm not sure if she can help me now. Will it be
okay.
possible, Ma'am Lorraine?
Wait lang, share ko lang yung screen ko.
Okay, for the actual demonstration, the controller is from the Philippines, but the robot is here at the UK. Thank you, Ma'am Lorraine.
Yan, sir, nakikita niyo yung screen ko.
Opo, ma'am. Pero yung HTML po, ma'am, yung i-open.
Teka.
Okay. I also shared in the chat box just now, sorry, the HTML code for the controller. After Ma'am Lorraine executes the code, maybe the viewers can also see the code and execute it for themselves. Just download it and open it in your browser. Oh. Oh no. Uh-huh. Or maybe I will just try. Will it be okay if I will just show it to you the actual?
Ayaw gumana sa akin, sir. Full.
Oh, ito na lang, ito na lang. Ito na lang. Can you see my screen now?
Alex, yes.
I'm using a laptop. I'm not connected with the setup. If you will download the HTML code that I shared to you, I have just a 1 minute. Sorry for the delay. Here's the actual. If I click this green, the green light will on. And then if this is red, the red LED will on. This laptop is not connected to the setup. You can slide the slider. The arm of the 2-degree robot will move. You can do this by downloading the HTML. You can open it using your web browser in the computer or in the from your cell phone. Below this web page is the connect the data from the DHT11. You can see this is the actual data logging here at my setup here. Okay, then you can try it for yourself by downloading the HTML code that I shared to you later after this presentation. This is really a telerobotic operation, the actual implementation of Internet of Things. Okay, I will now answer some of the questions, or maybe if I cannot answer all the questions, I will answer them later, or you can email me your questions, and I'm very willing to answer the questions. The ultimate goal of this presentation is for you to replicate this setup. I'm willing to help you to replicate this setup for online learning, online teaching, to demonstrate in real time, in real application, the Internet of Things, as well as the Industry 4.0, you may call it, as well as over-the-air programming. That anyone who is familiar with Arduino will not be having difficulty in doing or using these particle devices. For the only difference is the programming or the uploading of the firmware. Instead of uploading it directly to the device, you upload it through Web IDE. Okay. What is the first
Okay.
question?
Alex, this is your question. Is the security level of this device can be applicable in Industrial 4.0?
Oh, sure. These particle devices are now being used in the manufacturing all over the world. That there's a level of security. I think there's a level of encryption using the particle cloud. You need an account. You need to register an account, and all the devices must be registered to their cloud to be accessed or to be programmed using their cloud.
Thank you very much, Alex, for that presentation and for answering the question. We'll now be proceeding to our next presentation. Our next presentation is entitled Design and Development of a New Neural Network-Based Coconut Maturity Detector using Sound Signatures. This will be presented by Ms. Nemelin A. Fadshar from Mapua University. Ma'am, we can't hear the audio of the presentation.
Sir, I already sent that prior to the presentation. I think the Miss Atlas says that the presentation is already okay.
Okay.
Hi, Miss Fachar. Kindly mute your mic first.
Okay.
Thank you. Hello, sir. Good morning. Hello. Sir, can we proceed to the next presentation first? In the
Okay.
interest of time. Thank you. While we're fixing the audio for this video. Thank you.
As we are fixing the presentation, or our second presenter, we'll be moving first to our third presentation. So our third presentation is entitled Transfer Learning with Convolutional Neural Networks Towards Fungi Classification in Microscopy Images. This will be presented by Josh Daniel Laoong from Ateneo de Manila University. Mr. Ong, you may share your screen now. Josh, are you here? Mr. Ong? Hello, Josh.
Hello
Are you
po. Yeah.
okay? You may now share your screen.
Oh, sorry. I thought hindi pa time ko po. Pero yeah, sure.
Yeah. There are some technical difficulties from the second presenter.
Okay. So, mm, okay. Okay. Share screen. Hello. Can anyone see? Everyone see this?
Can see your screen.
See.
Okay.
We're starting now. Good morning, panelists and fellow attendees of the ENC 2020. My name is Josh Ong, and I'm here on behalf of my co-authors, and I'm here to present our work on transfer learning with convolutional neural networks towards fungi classification in microscopy images. Or masyadong mahaba yan, pero yeah, we'll get into that in detail later. But for a brief introduction as to the background of the study, uh, this is of course about the Patama disease or the Fusarium wilt of banana caused by a fungal pathogen known as Fusarium oxysporum forma specialis cubense, or as I will be referring to it for the rest of this presentation as FOC. Historically, there are many strains of FOC, but the most notorious one right now is Tropical Race 4 or TR4. And this affects the Cavendish cultivar of bananas, which is the most popular one being traded and exported today. Why is this important? Well, FOC-TR4 or Fusarium wilt has been known to cause plant death in infected plants by way of restricting their vascular system, cutting off nutrient supply to the rest of the plant body once it's infected. And currently, there is no known method of eliminating the disease once it has been found in soil or plants. Even drastic measures such as heat treatment or burning the soil has only been seen to temporarily halt the spread of the disease. How is this important on a global scale? Well, if you can see right here in the slide, there is a list of the top 10 producers of banana in 2018. As we can see, our country is on the list as number 6. We are also the second largest exporter of banana in 2017. If you noticed any of the countries listed in these two slides, most, if not all of them, have been and are dealing with the Fusarium wilt. And it's only been the problem's only been getting worse in recent years, where the Fusarium wilt has been seen to spread to new areas such as the Americas, where it has not been previously seen, because it was previously only found in certain regions of Asia and Australia, even going as far as to certain regions within those countries where it has not been seen before, such as Mindanao. Here is another close-up of the image used a while ago. You can see here these are visible symptoms of the Fusarium wilt. However, it is worth noting that these symptoms are not visible until very late stages of the infection, wherein the plant is completely colonized and has most likely started spreading to other nearby plants and maybe the entire plantation as well. This would make uh, plant disease detection methods that rely on visual or ocular methods such as leaf analysis less viable approach, since this would do minimal by the way of minimizing damages of what the disease causes. More comprehensive methods of disease detection exist, such as polymerase chain reaction, where the DNA of the plant or the soil is analyzed to check if the presence of disease is there. But these methods usually require expensive equipment and materials. So that's why we took the microscopy approach, where it is not as precise, but it could be made viable as a preliminary test. If you can see in this slide, these are 4 fungal structures that have been identified as to belonging to FOC or Fusarium oxysporum. While these inherently are not unique to FOC by themselves, the presence of all these 4 may suggest the presence of the disease. For related literature, as I've said previously, most papers on automatic plant disease detection focus on analyzing plant leaf for the infection. But as I've said a while ago, this is not viable due to the nature of the disease, only showing symptoms on plant leaves at very late stages of the infection. We also have some papers that use other multitude of sensors in conjunction with traditional plant leaf image analysis, like Esther Lim and Alampai's paper, where they used sensors such as pH, soil temperature, and humidity to map out the spread of the disease in order to effectively quarantine it. We also have Lim and Estuar study, in which very similar to my current study, where they use CNNs to detect the plant disease, to detect FOC or Fusarium wilt in microscopy images of soil samples. But there are significant differences between mine and their paper, which I will not get into detail right now for the interest of time, but you may ask if you want to in Q&A. For the methodology of my study, I used a data set that's comprised of soil samples or microscopy images of soil samples taken using 3 different techniques shown in the upper right corner right there, namely bright field, dark field, and fluorescent respectively. Each slide area was captured using these three techniques. And as you can see at the table below it, 4 labels were produced from these images, namely clean. These are images that do not contain any fungal structure whatsoever. FOCTR4, these are images that are belonging to FOCTR4 samples and have been identified and have fungal structures identified in them. And this is the same goes on for FOCTR4 and other fungi. Um, it's also worth noting that these a set of these three, these bright field, dark field, and fluorescent images, is called an image set, which is outlined in that second column in that table, and the total number of images is just times 3 because there are 3 images in an image set. I would also want to point out that despite being captured of the same area or same image slide area, these 3 different techniques produce different, at least in terms of features, different distinct images. If I want to highlight this, especially in the fluorescent image right here, where this area is more prominent compared to the same area in the bright field and dark field images. This is important as a basis for my approach in where I used ResNet 50's separate instance of ResNet 50 CNNs trained on each technique. Namely, I have a separate ResNet 50 trained on bright field, and then separate one for dark field, and separate one for fluorescent images. And then another fourth one trained on all 3 of them, regardless of what technique was used. For the weights, I have compared the performances of randomly initialized weights of ResNet 50 versus transfer learning using ImageNet weights. Input images were downscaled to 224 by 224 pixels, and the dataset was split into 80 and 20% train test split. These models were then evaluated using accuracy, precision, recall, and F1 score, your traditional popular performance metrics. Why use transfer learning? Well, transfer weights such as pre-trained weights such as the one in used by or produced by ImageNet are popular for object detection problems. And as you can see here from the image again, these fungal structures are fundamentally objects. So we expect to see an improvement over just randomly initialized weights when using ImageNet weights. And we can see that in the next slide where I outline my results. In here, we can see the improvement of the models when using ImageNet weights versus randomly initialized weights. For both cases, the bright field model was able to achieve the highest performance or test accuracy at 78.23% and 93.11% respectively. However, it is worth noting in this comparison that the all techniques model was able to benefit the most out of the use of transfer learning, because it was only able to achieve performance similar to the fluorescent model with randomly initialized weights. But when given ImageNet weights, it was able to achieve a performance more similar to the dark field model at 90.89%. Here is it in graph form to make it to show it clearer. As you can see, the jump from fluorescent and all techniques model when given ImageNet weights is significant. If we take a look at the individual models' performances with their precision recall and F1 score, we can see that the models tend to do well on FOC non-TR4 and FOC TR4 images. Like let's say here for FOC non-TR4 labels, the bright field model was able to achieve a recall score of 0.99. For the unfamiliar, a recall score of 0.99 would mean that it was able to correctly predict 99% of the FOC non-TR4 images in the test set, while a corresponding precision score of 0.94 would mean that out of the FOC non-TR4 predictions it gave during the testing part, only 94% of these were actually FOC non-TR4 images. So it had 6% of those images that it labeled as FOC non-TR4 were actually mislabeled. But as we can see here, for FOC non-TR4 and FOC TR4 labels, they were able to get good performance metrics. However, we can see that for other fungi, it was only able to recall about 80% of the images. And the opposite trend is seen for the clean images, where it was able to get a good recall score, but a corresponding lower precision score of 0.87. This trend persists similarly for the dark field model, however, with lower performance metrics across the board, except for other fungi label, where it was able to get slightly higher metrics. And for the fluorescent model, which is the worst performing individual model so far based on test accuracy, it was only able to achieve good scores on uh, clean, FOC, uh, clean and FOC non-TR4 label, but not it's not as significant as the ones we've seen in the bright field and dark field model. This can be explained by the nature of the images used in this particular data set, where some fluorescent images exhibit some overfluorescence or overexposure, leading to some bleeding in edges, which cause some loss in detail. For example, in these two images, if you look close enough in the bright field image example, you can see roughly where each fungal structure starts and ends, whereas in the fluorescent image, especially in the middle portion, you will not be able to really distinguish individual fungal structures from each other. For the all techniques model, surprisingly, it was able to achieve a performance similar to the bright field and dark field model. When given the image net weights to start with, this is probably the best example of why transfer learning was important, especially with this for this particular classification problem. And then, nope, accidentally went to the end. So the trends we've seen so far in these models is that they were able to perform well in classifying FOC TR4 and FOC non-TR4 images. This may be just because this may be explained by the consistency in fungal structures that are seen in these types of images versus the other fungi images, which is just a general label that contains many different fungal species under it. And similar to that, the models consistently achieve lower performances in labeling other fungi images. This because, of course, the other fungi label contains images of many different fungal species that only contain a few samples each, making it difficult for the model to learn exactly what features are or what fungal features are supposedly identifiable as other fungi compared to the clear-cut features seen in FOC-TR4 and non-TR4 images. Now, as an example, here are three different fluorescent images taken randomly from the other fungi label. As you can see, there is a significant difference in pattern, fungal shape, and size of the structures that are seen in these images. In conclusion, different CNN models were developed to take advantage of the properties of the dataset, meaning that since the dataset was created by taking images using three different techniques, we were able to kind of exploit that by training different models on each of those techniques, as well as one for all of it. And we were able to see that, at least for this particular data set, the bright field and dark field images were more helpful in identifying fungal species, while fluorescent images were only really helpful in determining if fungal structures were present in the image at all. The actual viability and effectivity of these models are yet to be tested, since these are lab cultivated samples and do not contain any soil, dirt, or other artifacts that are irrelevant that would be most likely present in a real world scenario. And of course, despite that, the models can work as a low cost preliminary test in determining the presence of fusarium wilt before maybe confirming it with a more comprehensive test such as PCR. Of course, the immediate recommendations I can give is to use pre-processing methods in maybe alleviating the problems that brought up a while ago regarding the fluorescent images. We can also use other CNN architectures to see if the modeling performance would be improved. And of course, the most important one will be to test it on real-world samples to see if uh, these could actually be this could actually be used as what I claimed it could be used for, which is a low-cost preliminary test for sorry mold detection. With that, I would like to give the floor to question and answer. Thank you for listening.
Thank you, Josh. Do we have any questions from the audience? If none, can I ask a question?
Yes,
Um,
po.
regarding your recommendation. So one of your recommendation is to explore other architectures of CNN.
Yes,
So
po.
for your study, what is the main consideration of your current CNN architecture? That's why you used it.
For our current study, we use ResNet 50 because it was shown to generally perform well on different image classification tasks. That's about it. There is no particular deep reasoning behind why ResNet 50 in particular. This is why I recommended that other CNN architecture should be explored. I want to elaborate that it's not general tasks that ResNet 50 was good at. We have seen papers that it has performed well on particularly biomedical images, which is why we decided on that as a base architecture.
Okay, thank you. Thank you very much, Mr. Ong, for
Yeah.
your presentation.
Okay. Will there be any more questions?
I guess we have no other questions. Do we have any other questions from the audience? If none, thank you. We'll be
Okay.
proceeding
Thank
to
you.
the third presentation. Again, the third presentation will be entitled Design and Development of a Neural Network-Based Coconut Maturity Detector Using Sound Signatures. This will be presented by Ms. Nemelin A. Fadshar from Mapua University. Ms. Lorraine, hindi pa siya nagpe-play. Most likely ma'am dun sa share computer audio.
Okay na?
Wala pa ma'am.
Wala pa rin?
Oo ma'am. Ma'am, can you send me the link? I'll try to if I can.
Okay, okay. Sent na po, sir.
So I'll be sharing my screen. Wait lang po.
Hospitable panelists, guests, participant of this conference. A pleasant day, everyone. Today I'm going to present my study entitled Design and Development of a Neural Network-Based Coconut Maturity Detector using Sound Signature, presented by yours truly, Nemeline A. Fachar, and my co-author, Dr. Jennifer C. De La Cruz.
Okay, so before I begin, I would like to give a brief overview of what is expected in this presentation. First is a short introduction of the background of the study. Next is the materials and methods used. Then the discussion of the gathered results. And finally, the conclusion and some of the recommendation to further improve the study. To start with, we all know that coconut, or scientifically known as Cocos nucifera L, is considered as one of the valuable products in agricultural sector. So why? Because different products could be derived from it, particularly in its fruit. And the quality of these coconut-based products was maintained through proper selection of the coconut fruit according to its maturity stage, which generally means that the maturity has a direct relationship to the product quality. But based on our current situation in the coconut industry here in the Philippines, farmers usually identify coconut fruit maturity through manual knocking or tapping and listening to its sound. Hence, a need to establish a systematic procedure for maturity detection is needed. This endeavor could improve the agricultural post-harvest processes, facilitate industrial sorting system, and maintain the quality of the end products. Studies has been conducted showing the potential of acoustic technique in determining the maturity level of several fruits such as tomato, melon, pomelo, cocoa, mango, watermelon, and of course, coconut. Likewise, related studies has been conducted using acoustic technique in determining the internal quality and firmness of several fruits such as apple, pear, pineapple, and kiwi. Moreover, past literatures on coconut maturity detection using acoustic properties has been conducted, such as measurement of young coconut maturity by sound waves, determination of physical, acoustical, mechanical, and chemical properties of fresh young coconut fruit for maturity separation, coconut fruit maturity classification using fuzzy logic, and the novel automated method for coconut grading based on. So, what is the gap? Since we all know that traditionally our coconut farmers still rely on the traditional manual practice of tapping or knocking the coconut fruit and listening to its sound, it is prone to human error, subjective judgment, and productivity issues. So to overcome this limitation, a growing demand for automated platform arise. This transition could modernize post-harvest techniques by using acoustics coupled with machine learning. In addition, this could uplift farming practices and standards along with higher system accuracy. The primary objective of the study is to design and develop a neural network-based coconut maturity detector using sound signature. Specifically, the study aims to extract the acoustic feature from the sound signal, train the dataset and develop the classification model using neural network, design and develop the prototype, and lastly, to test and evaluate the prototype. This endeavor is important due to the threats in global food security, which implies the sustainability of high quality products. For this reason, improvement must be made to the traditional approaches to overcome limitation and maintain the quality of post-harvest commodities, particularly by detecting the proper maturity stage. This could be done by applying the non-destructive approaches such as acoustic immaturity detection and exploring the potential of machine learning tools such as neural network and increasing the accuracy of automated platforms. Lastly, other prototypes for specific fruits for post-harvest commodity could also be developed by deploying predictive models and enhancing the accuracy of existing automated control systems. This study covers the design and development of a prototype for predicting the maturity stage of young coconut using 300 coconut fruit samples. The maturity stage of young coconut fruit considered were namely malauhog, malakanin, and malakatad. It was focused on extracting the sound signatures, pre-processing the sound signal to obtain the acoustic frequency using FFT, and training the dataset using neural network to create a classification model in order to determine the maturity stage of young coconuts. Python programming and TensorFlow was used to develop the program for the microcontroller. However, there were some limitations in the study. Other parameters or factors affecting the age of the coconuts, the detection of maturity level of a fully grown coconut fruit such as nyog, and the determination between usable and rotten coconuts, and the effects of storage duration after harvesting of the coconut fruits were not considered in the study. Okay, for the general methodology, it was composed of five major procedures, which includes the sound signature acquisition, the neural network modeling, the program development, the hardware fabrication, and lastly, the testing evaluation. For the sound signature acquisition, sound signatures were obtained from a total of 300 young coconut fruits, where we're in this 300 coconut fruits is composed of 100 samples from each maturity stage of malauhog, malakanin, and malakatad. So these sound signatures were obtained from the three phases of the coconut fruit as shown in the figure. Each phases was tapped twice and sound were recorded. In the sound signature acquisition, sound signatures were gathered using the experimental setup shown in the picture, which is composed of a vibration motor and a vibration sensor interfaced with an Arduino and a laptop. The collected signal was pre-processed by transforming the time domain into its frequency domain using FFT to determine the average spread of frequency spectrum of each sample. Then the dataset were recording according to predetermined class. For the neural network modeling, a two-layer feed-forward network with 10 neurons using the backpropagation algorithm was used to develop the classification model in this study. For the program development, Python programming was used in developing the software for the prototype. And of course, since the MATLAB neural network model was need to be translated into a TensorFlow model because there is no straightforward method that allows a MATLAB script to be incorporated into a Python script. So the Python script implements the TensorFlow model and reads the data from the input and performs the classification to produce an output as shown in the program. For the hardware fabrication, basically there were five major components that was used in this study. It is the vibration motor, vibration sensor, the Raspberry Pi 3B plus microcontroller, the rechargeable battery, and the LCD. Well, for testing and evaluation, um, to ensure the accuracy and reliability of the vibration motor and the vibration sensor, it is calibrated using the DT2234C non-contact high-low speed digital tachometer for small motors. For the testing and evaluation, it is done in two parts. Basically, we have a preliminary testing prior to the final evaluation to determine if the parts were working properly and if calibration is needed to be conducted. So based on the gathered results, the sound signature of the three types of coconut fruit as shown in the figure shows different distinct characteristics from one another. The Malauhog has the lowest average power and then followed by Malakanin, while Malakatan has the highest average power, which supports the results of the previous research done by Gatchalian that explains the transition from solid to hollow sound as the coconut matures from Malauhog to Malakatan. And also, the figure shows some of the selected samples from the training dataset and plotted on a bar graph to show the relationship between the frequency and the maturity level. So as you can see, there is a clear relationship that distinctly identify the maturity stages of the coconuts. So as you can see, here is the neural network model confusion matrices. So an overall classification of accuracy of 91.3 was obtained from the neural network model. So the results indicate that the model has a high percentage of predicting the maturity stage of young coconut fruit accurately using the given data sets. Moreover, this implies that the model could be implemented to further evaluate the accuracy on actual conditions. The picture shows my final prototype. The location of specific parts such as the vibration motor, vibration sensor, the power switch, the charging port, and the scan button. So for the results of the pilot testing from the 10 randomly selected coconut and the final evaluation of the 50 randomly selected coconut fruit. Um, so as you can see, during the pilot testing, the device has predicted 9 out of 10 correct maturity stage as compared to the manual practice, which gathers 8 correct predictions out of the 10 samples. While for the final testing, for the 50 randomly selected coconut, results reveal that predictions done manually obtained a prediction accuracy of 85% for Malauhog, 90% for Malakanin, and 94% for Malakatan. Meanwhile, the prototype acquired the following prediction accuracy: 98% for Malauhog, 95% for Malakanin, and 96% for Malakatan. So for the comparison of prediction accuracy, An overall accuracy rate of 96.33% was gathered by the prediction done by the device, and then an 89.67% accuracy was gathered by the manual prediction. Lastly, for the conclusion, results revealed that the developed prototype was able to classify the three commonly known maturity levels such as Malauhog, Imalakanin, and Malakatad using the sound signatures. The frequency information was successfully extracted and was used as a feature vector for neural network modeling, and the developed neural network model obtained a classification accuracy of 91.33%, which indicates a high prediction accuracy, and the developed prototype has a higher accuracy rating of 96.3% as compared to the manual practice of 89.67%. So for the recommendation, it is encouraged that future study should include the duration of storage of coconut fruit, weight of coconut fruit, volume of coconut juice, and other chemical properties. Further evaluation of the prototype on the efficiency and functionality is encouraged for future research in order to improve the device and meet industry standards. And lastly, the glimpse of references used in the and thank
Thank you, Miss Nemelin. So, do we have any other questions coming from the audience? Any question? I guess we have one question.
Yes,
We
sir.
have a question. So the question is, does the angle where to place the device affects the results?
Um, During the yes sir, the angle where to place the device affects the sound signal. During the sound signal collection, it is necessary that you put the vibration sensor and the vibration motor on the faces of the coconut because it is where the flat surface lies.
So we have an optimized certain angle for the testing, right?
Yes, sir. It should be placed on the faces because a coconut has what we call three faces and three edges. If you place the vibration sensor and the vibration motor along on the edges, it will not give you an accurate prediction of the maturity level.
Okay. We have one more question. What is the
Yes, sir.
variety of the coconut used, and will it not affect the results?
The variety used was the Laguna Tall variety coconut because it is abundant here in our place in Cavite. I guess it should be included also in the recommendation that I don't know if the other coconut varieties has the same surface structure with the Laguna Tol variety because as I have seen other coconuts, some of them are very round, so you cannot determine the faces as I have mentioned earlier. But for the Laguna Tol variety, you can immediately identify the faces and the edges of the coconut.
Thank you, ma'am. I guess we're done with the Q&A. Thank you, Miss Nemeline Fadsar. So we're now moving to the last presentation. So our last presentation is entitled Vision-Based Approach for Checkpoint Status Analysis. This will be presented by Sirotoni Gail B. Yaon from De La Salle University.
Engineer Eric, I'm going to share my screen now. So I'm just going to conduct a series of tests before I begin. Can you hear me clearly, engineer?
Yes, we can hear you. We can see
Okay.
the presentation.
You can also see my screen. Just one more thing. Can you see my slides transition to the outline?
No. Yeah, we can see here the outline.
Okay,
Yeah.
thank you. So I will begin now my presentation. So good morning, everyone. I am Cheretoni Yaon. Together with me today are my teammates Jonathan Sempron and Dr. Joel Ilaw. I will be presenting in behalf of our group the work we did on vision-based approach for checkpoint status analysis. This outline explains how quarantine checkpoints were examined using vision-based techniques. So just a brief background of the study. Checkpoints, also known as quarantine control points, are areas placed in the city boundaries and municipalities intended to regulate and limit the mobility of people to essential travel and to arrest the spread of novel coronavirus. Checkpoints, like any other queues, introduces delays and bottlenecks. In the current context of QCPs, the goal is to balance the trade-off between minimizing the inspection personnel and maximizing the processing in security checkpoints. To achieve this trade-off, it is essential to identify what is the present condition of the checkpoints. One way to assess the quarantine control points is by estimating the fundamental parameters practiced in traffic engineering. By having useful insights on the number of vehicles that needs inspection, the arrival process for the vehicles, and the number of inspection personnel which controls the queue, we can evaluate its performance. So, this research aims to answer the question, can we assess the QCP performance surrounding Metro Manila using traffic video feeds? And our goal is to approach this problem using vision-based technique. So for the object tracking and lane identification, we developed a detection-based tracker from our previous work that implements a predict, match, update framework. This tracker takes in an input video, the picture on your screen, and then it outputs a file called track list. So this track list holds a list of data called track points. The track point file contains the following information: frame numbers, vehicle classification, and bounding box information. We use this track point info as the basis for our analysis. The track points contain our trajectory information. It is the lines that we are seeing in the picture. But the problem is the system does not know which lanes these track points belong to. That's why we have to perform this entire process to achieve this info. So we implement a partitioning on the track points because the vehicle's trajectory becomes inaccurate when it starts to exit the scene. So for more robust analysis, the track points were divided into three regions: upper, middle, and lower. The threshold for separating these regions were based on manual observation on the track points and the scene. Each of these partitions were clustered. Then the cluster that produced the best outcome was selected to impose the membership on the lanes. The figure you are seeing, the last figure you are seeing. The color bar in the figure represents the lane in the scene. So for the data that we use, we perform the analysis using videos showing checkpoint operations held at EDSA Star Mall, Mega Mall, and Guatix. The videos were recorded on dates covering the quarantine periods ECQ, MCQ, and GCQ. We used the 5-minute chunks of these input videos between 9 a.m. to 11 a.m. In this analysis, we use the terms upstream and downstream to represent the roads. A road is said to be upstream if it moves away from the camera. It is downstream if the vehicle moves towards the camera. So Guadix is an upstream, EDSA Star Mall is a downstream, and Mega Mall is both. Our analysis is limited to the scenes where the inspection areas are visible to the camera. In the Marikina Infanta Highway scenario, the left figure, the inspection area is undetectable because the vehicles are too small. Likewise, the scene on EDSA GT Tower, the right figure, shows the vehicles are undetectable because the camera is too high. We did not include these cases in our analysis. So for the proper Q analysis experiment, this figure shows the Q system parameters we use. L sub I serves as the lane in the scene. Service rate, denoted as capital Q, is the number of vehicles processed at the Q system for each unit of time. Arrival rate, denoted as small q, is the number of vehicles joining the queue over a period of time. The number of personnel assigned to an inspection area is symbolized as capital P. And lastly, T represents the time, which in our case is 5 minutes. The left figure shows an example of a series queue system, wherein multiple vehicles are served in a single lane per unit of time, while the right figure shows a sample of a parallel queue, where multiple vehicles are served in multiple lanes over a period of time. Given that the security location in the actual input videos are changing per location, as seen in the previous slides, there are locations that are both upstream and downstream. We assume that the checkpoint areas in the study follow a parallel queue, where the enforcer is located at the head of the queue. So we discussed earlier service rate and arrival rate. An important consideration in arrival rate is that we base the tail of the queue on the first instance the vehicle is detected and tracked as it arrives in the queue. In this analysis, we will be using the two variables service rate, capital Q, and arrival rate, small q, to determine the saturation level of a certain lane. A lane is marked as optimal if the number of vehicles processed is equal to the number of vehicles joining the queue. Meanwhile, a lane is oversaturated if the number of vehicles processed is less than the number of vehicles joining the queue. Lastly, a lane is undersaturated if the number of vehicles processed is greater than the number of vehicles joining the queue. So this is just a summary of the saturation levels I discussed earlier. So applying this analysis to our selected checkpoints, Table 1 shows saturation levels for EDSA Star Mall. We can see that Cluster 1 and Cluster 2 yielded optimal results, while Cluster 0 is marked as undersaturated. In the figure, we observe that Cluster 1 and Cluster 0 are merging because in the actual video, there was a roadblock before the inspection area in Cluster 1. We expect Cluster 0 to process more vehicle trajectories on this scenario. However, we notice that overlapping points in Cluster 0 are not counted. Table 2 shows the saturation level in Mega Mall are all optimal. We observe that the size of the queue is shorter compared to other locations. Although the inspection area is visible, a fence blocks the arrival scene for Cluster 0. The camera view for clusters 1 and 2 are also shortened. These factors might have an effect in the results shown in Table 2. For the last location, Table 3 shows the saturation level for Guadix. Cluster 0 is undersaturated and cluster 1 and 2 are optimal. We notice that vehicles arriving in cluster 0 are visible to the camera, but it becomes undetectable as it exits the queue. The switching of lanes between cluster 0 and cluster 2 are also not accounted for the same reason. So overall, in conclusion, in this study, we present an algorithm to calculate the service rate, arrival rate, and saturation levels of quarantine control points or QCP using vision-based method. We gain valuable insights to what factors should be taken into consideration in design queue analysis. Our work is able to identify the lane membership under different QCP locations. We are able to classify the checkpoints based on vehicular volume in the queue. And we are able to determine the inspection service efficiency, lane capacity, and behavior of QCP locations. Further enhancements have to be made on handling the overlapping trajectories, setting of thresholds for queue system parameters, and recognizing the service areas in the actual input video. Also, the measurement of the algorithm's effectiveness is accomplished in another study. So we have a separate paper for the algo performance. This analysis is focused on the application aspect of the vision method. Overall, our work could be used to automate the estimation of traffic congestion levels at sections covered by surveillance cameras. It can also be used to measure the level of service in managing vehicular traffic. That is the end of our presentation, and thank you for listening.
Thank you, Ms. Tony. We'll now be accepting questions from our audience. Any questions from our audience? If none, may I ask question, ma'am, regarding one of your recommendations?
Yes.
For the future researchers, what might possibly be the best, yung pinaka-starting point as they continue your research?
For future researchers, they might check the setting of thresholds for the queue system because right now we are depending on what we are seeing on the screen. If they are able to determine an data-driven way to about the arrival in the scene or in the inspection areas, then they can improve this study.
Related, ma'am, to the threshold, have you provided the threshold from your initial study too? So at least the future researchers will have a reference, as you mentioned yung threshold earlier.
Oh, for the threshold, we base it on the manual observation on the scene. So it depends on the location. So right now, we have an ongoing study on how to determine the threshold, but it is not yet included in here.
Okay. Thank you, ma'am. Do we have any other questions? If none, thank you very much from our last presenter, Ms. Yaon. So we'll be having around 10 minutes.
May question ata, sir.
Yeah, we have one more question. Ma'am, did you consider how different environment conditions will affect the video feeds? For example, lighting and weather-related conditions like fogginess.
Yes. The system was tested on daylight scenario and night scenario as well as rain scenario. So for daylight scenario, we are able to get the same features that we use in the study. However, for the night scenario, it is expected that there are certain features that are available in the day scenario that are not available in night scenario. So we can expect that there are the accuracy level will decrease on night scenario. So for the rainy scenario, it would depend if it's day or night.
Okay. Thank you, ma'am. Have any other questions? If none, that ends our 4 presentations coming from De La Salle, Mapua, Ateneo school. So we'll be having around 10-minute deliberation as the panel decide for the best paper. So we'll be back as we announce the best presentation.
Hello, good morning, Sir Erickson.
Yes po.
How do we deliberate yung panel? Or yung score na lang dun sa grading? Ano?
I guess, ma'am.
Hi, sir po. Dun po sa spreadsheet po.
Yun na yan. Okay,
Opo,
thank you.
yun na po. Thank you.
Thank you, thank you. Thank
Thank
you,
you
Sir
po.
Erickson.
Pwede bang si Dr. De La Cruz ang mag-announce ng result ng deliberation?
Good morning, Doc Jonas.
Hi, good morning.
Yes, sir.
Phoebus, pwede bang si Dr. Jenny na lang ang mag-announce ng result?
Pwede naman. Ma'am Jen.
Overexposed na ako eh. Si Ma'am Jen naman.
Good morning to all. Good morning, everyone. Good morning to all the...
Or kung hindi si Ma'am Jen, si Mike naman.
Hindi, Sir Mike.
Si Sir Mike na. Hindi, si Sir Mike na kasi co-author si Ma'am Jen eh.
Opo, pwede.
Ikaw na.
Doc Mike, ikaw na.
Anong gagawin ko, sir? Announce lang, sir.
I-announce mo lang.
Okay, sir. So, kailangan pa ba, sir? Pakita ko pa. Wag na lang, sir.
Hindi na siguro.
Okay, sir.
Ranking na lang.
Okay yung rank. Ano pa ba ng ranking, sir?
Kahit tanong natin sa secretariat. Secretariat, please.
No need na po, sir. Yung best paper na lang po.
Okay. Sige, sir. I-announce ka na, sir?
Thank you, Sir Mike.
Okay, sir. So, thank you for attending our ENC 2020 or ERDT National Conference. So, I will, based on the deliberation of the judges and the scores that is tabulated from the panelists. So the best paper award will go to the paper entitled Design and Development of a Neural Network-Based Coconut Maturity Detector Using Sound Signature. So congratulations on paper number 2. Okay.
Thank you, Mike.
Thank you, sir.
Congratulations.
Congratulations.
And now we've come to the last part of our program, which is the closing remark by the project leader, overall program leader from the University of the Philippines and College of Engineering, the uh, Dean Ferdinand Manigdeg. Could you kindly play the video?
Hello, ma'am. Wala pong audio ulit.
Ay, sorry po.
Ma'am, once you share screen, may button doon sa baba na use computer audio. Reshare nyo, ma'am.
Thank you po. Miss Maybe, wala pa ring sounds. Before po sharing, pa-click po yung computer schedule.
Hello, can you provide me a share screen? I'll try to run it from my end.
Hello, Dean. Good morning. Sorry for the delay po. Yes po, sir. You can share your screen na po.
Can you see it now?
Yes, sir.
Yes, sir. We can see it now.
Okay. Pasensya na po at hindi malakas yung signal ko dito sa bahay. Pero anyway, here's my message.
To the members of the Engineering, Research and Development for Technology National Conference Steering Committee, plenary speakers, session chairs, ERDT project leaders, the UST family led by Honorable Secretary Fortunato de la Peña, participants and guests, a pleasant day. I want to congratulate and thank the ERDT National Conference Steering Committee and all its staff for all their hard work in making this conference a reality. Despite the current limitations and challenges, we indeed had a fruitful conference with equally relevant technical sessions in energy, environment and infrastructure, information and communications, manufacturing and machinery, semiconductors, materials and electronics. Thank you to our plenary speakers, chairs and presenters who made each session a fruitful learning experience for everyone. For the past 5 days, we have been immersed in the outcomes of 31 fantastic and exciting research from the different ERDT consortium universities. We heard talks about innovative processes on energy, new environmental technologies, disaster-resilient infrastructures, systems analysis and process optimization, and the development of highly functional machinery, to name a few. Early this year, the world was startled by this pandemic. Everything was brought to a sudden halt, from education to industry, from business and economy to society and anthropology. Over the course of a few weeks, life as we know it was gone and was replaced with the so-called new normal. What was previously a future teeming with potential was replaced with one filled with anxiety and unprecedented darkness. As researchers, we are not spared from the effects of this pandemic. Laboratories were closed or access was restricted. Our research was significantly hampered and outcomes were considerably slow. But despite this, we still found ways to conduct research. research to be productive and not be crippled by this pandemic.
Good morning,
Scientists,
Dean. May I know,
engineers,
sir,
and researchers
when you stop po?
ways of learning, working, and even socializing. This year's theme is bouncing back into the new normal. And this conference is indeed a significant bounce back, springing into action and a testament as to how we have overcome some of the unique challenges of 2020. It is encouraging to see that the ERDT community is indeed robust and brimming with vigor even at this time. If you could indulge me a few minutes, let me also share with you some of our own bounce back at the UP College of Engineering. We have realized for some time that research involving simulation and mathematical modeling is emerging and will be playing a significant role in this new normal. Thus, last August, the UP College of Engineering, in cooperation with the UP Engineering Research and Development Foundation and the UP Alumni Engineers, launched a fundraising project that will finance the creation of a state-of-the-art high-performance computing laboratory at the college in 2021. Once this computing laboratory facility is in place, complex simulation and numerical computations that usually take weeks to process and finish using clustered laptops and computers would only take an hour. This implies a tremendous increase in research productivity and improvement in research quality. The support of the UST is also most welcome in this endeavor. As we collectively maneuver through this pandemic and face a future that is uncertain, to say the least, this conference has given me fresh hope that we can indeed overcome this challenge of COVID-19 and any other challenges that the future will bring. I wish everybody an advance Merry Christmas. And a prosperous New Year. Mabuhay tayong lahat.
Thank you, and that concludes our ERDT National Conference 2020. So we'll be seeing you by next year for our ERDT National Conference 2021. Keep safe, guys, and thank you.
Thank you po.
Thank you po. Salamat.
Thank you. Bye-bye.
Thank you.